evening, friend. Now from the metallurgy exercise problem we are going to solve. So let us read out the problem number one. Copper can be extracted by hydrometallurgy, but not zinc. Okay, this is the question, student. Uh, First of all, let us know that is what is hydrometallurgy. Then only you will be able to understand that is how the copper can be extracted by hydrometallurgy, but not zinc. So let us take a student on the board. So first of all, let us understand that is what is hydrometallurgy. Hydrometallurgy. Ab hydrometallurgy means what, that is first of all whatever the metal is there, metal. In the step number first, what we will do is step number first, dissolve in suitable chemical. Dissolve in chemical. Okay, suitable chemical. And then that is what is, if you are dissolved in chemical, so metal will convert into the iron. Then reduce the iron. Then what we are doing, reduce the metal ion. What can we write? Reduce the metal ion by what? Metal ion by, that is reduce the metal ion by what? You can reduce, student, by the H2 or by H2 or more reactive metal. More reactive metal. Now if you want to see that is how you can be able to do, so let us try to understand with the example, student, if you want to understand. So when you are talking about, suppose if you are taking, that is if you are having the copper, okay, copper ore. If you talk about the copper ore, suppose it is that Cu2O. So Cu2O firstly converted into the, okay, so when you dissolve this Cu2O, so it will give, that is 2Cu, okay, plus 1 by 2 O2, okay. So this Cu, when you are taking this Cu, dissolve in the, if you suppose if you are dissolving in acid for particular copper, you can dissolve in acid. So suppose if you are having copper acid, no, suitable chemical acid, it can be acid or it can be base or it can be, that is bacteria also. So depending on what you are doing. So copper you take, student, and you dissolve in this one in the acid, okay. So if you are dissolving in the acid, it will convert into Cu2 plus, okay. Now this Cu2 plus has to be reduced. Take this Cu2 plus and react with the hydrogen. So what you will be able to get, student, you will get copper solid plus you will get, that is 2H plus. So what we are talking about, that is copper can be extracted by hydrometallurgy, but not zinc. So the reduction potential, if you talk about zinc, iron, are the lower, very much negative, student. And if it is very much negative, if you talk about the zinc, one more region where is a zinc, that is it is a very negative value is there, okay. Reduction potential value is negative. Negative is there, so if you put, that is del G is equal to minus NF and E naught, and this is negative and this is negative. So negative become positive, and positive, it means if it is giving positive means non-spontaneous. But when you are talking about the copper, student, copper is having the positive value of, that is if you are talking about copper, E naught cell of the copper, it is like that plus 3.4. So 3.4, if you talk about, here is the, if you are going to calculate, that is G, okay. So G is equal to, it will come, student, it will come, that is negative. For the copper it will come negative. Negative means spontaneous, but for other zinc it is coming the positive, and positive means non-spontaneous. So that is zinc cannot be extracted, student, but the copper easily can be extracted, okay. Now let us move the another question, student. What the other question is there? Okay, other question is there, what is the role of depressant? What is the role of depressant in the fruit flotation process? Dear student, during the lecture I already explained, that is the role of the depressant is that to separate the two ores, okay, two sulfide ore. Now let us read out the slide, student. In the fruit flotation process, the role of depressant is to separate two sulfide ore selectively, preventing one ore from the forming froth. For example, to separate two sulfide ore, ZnS and PbS, okay, ZnS is there and PbS is there, okay. If you want to separate these two ore, so what we can do is, student, you add, that is NaCN is used to depressant. NaCN is depressant. Now student, when you are talking about NaCN, which is selectively allow PBS to come from the fluid, so that is ZNS allow, NaCS allow to form what student, to form PBS to fourth, fruit only, that is the PBS to fruit. Now what they are saying, uh, to but the preventing ZNS from coming to the fruit. This happen because of NaCN react with ZNS to form Na2ZnCN4. Okay student. So what they are saying student in this one, if you are going to try to understand this concept, so here you can learn from the board student. So ZNS is there, NaCN you are using the ZNS and PBS is there in the your ore. So when you are doing to concentrate, so what is it? NaCN depressions only NaCN allowed to form PBS to form froth. Okay, so froth is forming PBS, not Zn. Okay, so NaCN here we can write NaCN does not allow, okay, does not allow ZNS to form froth to fourth. How is student, how it does not allow to form the froth? Because it react with the ZNS, it gives the complex compound. So see student, 4 NaCN is there, and if it is reacting with the ZNS, so what it will give student, it will give that is Na2 and square bracket, it will give that is ZnCN4, ZnCN4 square bracket close, and what it will give Na2S also. So this because of this compound, Zn will not form the froth. So this is all about the question number 2. Now let us move question number 3 student.